they still have like, they're trying to change it. Don't want not.
Hello, welcome. Thank you for listening. This is basically an early stage exploration of PostgREST and Newt, but I was going to include some background. I've been working in the library setting since 2015 at CalTech, and one of the things that struck me about all of our applications, whether it's institutional repositories or catalog systems, is they're vastly too complex. And that's got me to think about how can we break those down to sort of simplify our stacks. And what I've realized is that we really have sort of three general abstractions we want to work with. We work a lot with JSON APIs, so there's sort of some sort of JSON source, data source managing, giving us the truth about our data. We often have template engines incorporated in our systems, or some way of rendering that JSON as a page. And the missing piece sometimes is how we handle routing of the request to those two systems and getting back a result. If you're programming in Python, let's say Flask or Django, you're writing a bunch of route statements. If you're working in PHP, similar. I'm going to walk through really quickly three different implementations of a very simple bird sighting website. There is no visual design on this. This is raw HTML. That's on purpose. One, I'm not a designer. Two, I wanted to focus on that back-end conversation. The first one is static site. We render with Pandoc, with CSV files, our data source. And this last two are dynamic systems. And I want to look at the trade-offs in them. So the first one is pretty small. You know, it's got a README. It's got the CSV file template, and then that renders the index HTML. If this was in a GitHub repository, it'd be 75 lines of code, pretty tiny. All right, that's good, and it looks unimpressive. It's just a simple table with birds. Now, the problem with this, of course, is that if I want to update my list of birds I've cited, I have to go back, add that to the CSV file, and then re-render it. If I'm at home, that's fine. But if I'm out and about at the park, not as convenient. So that sort of brings us to version 2. This next version, this is where things got interesting for me a couple months ago. Historically, we were a MySQL shop. We're becoming a PostgREST shop in terms of our relational database backend. And I stumbled on something called PostgREST, which basically, with a little bit of configuration, gives you a JSON API sitting right on top of your database. Why is that significant? It means you model your data in your database, your middleware is done. I spent most of my career writing middleware. This sort of, that's gone. I don't have to write that code for the 1,000th time. So that's kind of cool. Now, going from the static to the dynamic, there is a code increase, right? So we went from about 75 lines, of which 30 were generated by Pandoc. We're now at 200 lines. So a little bit more code. Still have my CSV file as my initial data set that gets loaded into the database. I have a setup SQL file, which basically configures PostgREST to talk to PostgREST. And then I have my models, which is just a SQL file with some create statements, and I create some views, and I create a function or two. And then I have a simple PostgREST configuration file. And since we want HTML rather than raw JSON, I need to have a static type site talk to the PostgREST API. So let's take a look at that. As you can see, it looks a lot like the first one, except we got a web form. And so in this one, let's say I saw stork. See if I can spell stork right. And I saw it Harper, Korea. And let's say I saw it on the 4th of July. I had my bird sighting. It's in my list. What happened here? There's a static web server hosting that index HTML. It's got JavaScript. It talks straight back to the PostgREST API. Now, this is a dev environment, so that's just what I run. And in the real world, you would proxy back to the PostgREST interface because it's going to be running on localhost, so you can keep it tight. Let's take a look at some of that code. So the setup is pretty simple. My SQL files are a bit verbose. I apologize. I have to comment things because I forget. So the number of commands in here that you're actually doing are pretty small. That first one, /seek birds, is just connecting to the birds database. I set up a schema. Schemas for me in the Postgres sense were new. I think of them as a namespace. In the MySQL world, you don't really have that. I create my schema, so that gives me my namespace. I create a role for an anonymous user, birds and anonymous, and that seems to be a theme in the PostgREST community. They tend to have an anonymous role with some default read capability to the API. And then I create a birds role, which is a role that's going to be more privileged. And at the very bottom, I grant all the anonymous rights to the birds role so that it accumulates rights. So that's pretty easy. That basically is allowing PostgREST and Postgres to talk to each other. As I mentioned, I'm modeling my data in the relational database, and I do want to mention that modern relational databases support JSON columns, so you can't think of it as the old Cobb's rules anymore. Not that they were ever that great. It's really, you can have you can think of the database as a key value store where I'm storing JSON blobs in a key column. You can think of it as a fully relational model, whatever you want to model it. That's available to you. So I have some boilerplate at the top here that I connect to the database again. Excuse me. I set a search path, and this is something that again has to do with the namespaces. This is new to me, of course, that's new to Postgres. I wanted to look at my birds namespace first. It doesn't find something there. It's in the public space of Postgres. To me, public means global space of Postgres. Simple data model. It's a simple table, a bird, a date, where I saw it. Not complex, but this could be a much more complex model. It could be a model of metadata, like a cross-ref or a data site thing in theory. Create a view. It's pretty straightforward. I create a function. Now, I created a function for two reasons. One is, generally speaking, when we receive data, when we're going to do a write, we want to do some additional vetting. And this is where you can actually intervene and do some additional vetting. The other advantage of a Postgres function is that if you don't like SQL, say you like Python or Lua or something else, you can switch to that language as long as Postgres supports it. And Postgres supports a lot of languages now. I was kind of shocked. But I'm going to stick with SQL because I'm an old guy. And then at the bottom of this model style, I've gone through and granted additional permissions to allow PostgREST and Postgres to interact. Why did I put this in the model style? What I found through my initial experiments was, as I adjust my models, I often want to adjust privileges. And so they're very tied. And so I just kept them in the same spot. Gotta get my machine to wake up. One second.
Sure.
Oh, there it is. think. Sorry about that. I'm rusty. So basically, when I combine those two, I have my models, I have my PostgREST. PostgREST gives me a nice JSON API. I can talk to it. The problem I have with this approach, I've used this approach for internal apps inside CalTech, not with PostgREST, but with other JSON APIs, is that if you turn off JavaScript in the browser, your form goes away, right? It's not going to work. And that can be really frustrating because if your JSON service happens to drop out and say library staff at Circus using your application, it just doesn't work. And that makes them uncomfortable. So that's the problem with this approach. So that led me to a third incarnation. Oops, too far. Which I call BERTS version 3. And what I realized the missing piece was data routing and sort of vetting of the inputs in an additional way. So in this third version, I implemented it by creating a program I call Newt. And as you can see, the files in this version are very similar. We still have our BERTS CSV, we still have our setup SQL, we still have our model SQL. I have a models test SQL. What we have different is a BERTS YAML file. And this BERTS YAML file basically is where I'm going to define our routes. So So as you've seen in other configuration files, this looks pretty straightforward, I think. I'm not necessarily a big fan of YAML, but it seems like a lot of people like it, so I used it. I have an attribute called routes, and at each route, I define a set of attributes to respect. In this case, this BERTS website is just sitting on a root, so it's just sitting as a root. There's a get, so that's the default thing that happens. I then say, all right, the API content, the JSON data source has a content type as expects, in this case, application JSON. I'm going to pass that get from the root object to a get on the API side. And I'm going to use this URL, localhost 3000 word view to get back my data. Newt has a little bit of cleverness it's not shown here, which is that a lot of times you want to transform your URLs. And so it has a little way of defining some variables and doing some variable substitution. So if you look at the log path, you could translate that into a PostgREST API call. More than I could share in a half hour. I also have a next piece, which I didn't mention. So we still need to be able to build the web page. And all the different systems I've used over around 20, 30 years of software development that around templating, none of them are standard. The closest thing I've seen to standard is Pandoc, because it translates everything into everything. It also has an explicit template language, which is really simple. It gives you enough to drop things into the page, but not so much that you embed business logic. And I think that's really important because the systems I work on that have a lot of commingled logic, say ePrints, it winds up being a very brittle system and very hard to maintain in the long run because of that commingling. So I chose to use Pandoc as my backend. Pandoc has this really clever feature since version 3, which is if you say Pandoc server, you have a JSON API for the Pandoc. You send it a JSON package that includes your JSON data and the template, and it gives you back something. And in this case, HTML pages. So that worked out really kind of sweet. And so the third version of the website, again, looks familiar. I'm actually using the same PostgREST instance. So I'm going to reload this so I get the extra thing. Well, I'm going to add another bird. Actually, a bald eagle. Catalina. Maybe I saw that on the 10th. Fucking type. Not be nervous. There we go. Now, the neat thing about this version, by putting that very thin application layer, that microservice, on top of the other two microservices, is that there's no JavaScript. I can go to this website with links. Any text browser still works. That also means that you can treat the website as an API because it's curlable. So the implications of that is pretty big. The other thing is you can decide to pass through your JSON, your PostgREST JSON data source if you want, and that becomes nice with views. So as an example, with NVIDIA RDM, it has a rich JSON API, but it's rate limited because some of the operations are expensive. So you wouldn't want that hanging out in the public, but you probably have some stuff you do want hanging out in the public. Right? Maybe you have a vendor who's harvesting stuff for aggregation. So I don't think I changed the code on this, but let's see if I. We'll see if the demo gods are benevolent. Nope, they're not. Oh. Helps if I use the right. I created in that YAML file, I created a additional route, which I prefixed with API, to give me the bird's view. So that just passed through the API. So I can selectively define public APIs, have them hang off the public website. Those are safe things because I create them as views. There's safe select statements that aren't going to kill my system, right? That's, to me, is really interesting. When you think about how we use ePrints at CalTech, we create a site called feeds.caltech.edu, which then directly incorporates into the campus CMS a view of all the publications by our faculty and staff and researchers. That's huge. Library now is central to the output of the institution. So these are some possibilities with not a lot of coding on the back end, right? I wrote some SQL. So that's sort of what it does. Just to show you the view from this is from Postgres itself, right? So it's the same data. That's why it's the same data. So anyway, what this kind of led me to believe, or to, in the end, is some conclusions. One, from a few off-the-shelf microservices, we can construct full applications. When I look at the NVIDIA stack, you know, they've got Redis running, they've got almost containers running, they've got Postgres running, they got a whole set of Dockerism. I mean, it's just this mess of a stack. And while it's far superior to ePrints in terms of its complexity and legacy in Perl, it's still ridiculously complicated, right? So can you assemble a service from off-the-shelf parts? The answer is yes. That's great. I think orchestrating the data pipeline, where the pipeline is deliberately kept simple. Essentially, I have a JSON data source. I run it through Pandoc. If I define a template for that Pandoc is going to respect, and I give back data, or I just echo the data back in the JSON data source. That's huge, because it could be any JSON data source. It could be orchid.org. It can be anything, right? It can be Crossref. They all have JSON APIs. So now you can pull those in to your space. That's kind of cool. SQL does turn some people off. A lot of people like keep SQL at arm's length. They use an object relational mapper because, oh my God, it's SQL. So that turns people off. One of the things I'm exploring is, can I define my data models in YAML? And the answer is yes. Because I created a typed language to describe the variables that go into a URL, I realized that that's also maps correctly into SQL, in theory, into any other type of language. So that's something I'll be adding in Newt. Pandoc templates are pretty simple. They're well documented. So I think that's a low hurdle to adoption. What I've done with Newt is plays really nice with HTML5 static. Yeah, Newt also provides static file services, but that's sort of blasé. So you have a nice way. If you were using the Figma stuff, that still can work on top. It's just talking back to the data source. So that's kind of cool. I also encountered a really unexpected result. When I started this project, I was thinking, how can I simplify? How can I scale down to the small size that is CalTech? We have like 2,000 students, right? We're tiny. I deliberately took the PostgREST model of how the application worked. It was a microservice. It basically, when it starts up, that's its state. It's not maintaining a state. It doesn't have to talk to other systems to maintain state. It can just spin up and can run in parallel. You can have lots of PostgREST standing next to each other. So I thought, well, Newt should do that. Pandoc literally is so simple. It doesn't even produce a log. There's nothing, no writes to disk. It just runs in memory. So that's, again, I took a page from that. How do I make Newt fit that model? And that was sort of just a intuition. That wasn't a deliberate choice. Postgres can run an HA in a high accessibility cluster. So it can scale really big. And then that made me realize Newt can scale really big. While I was targeting the small, right? It's common for our systems to run on AVM. We still have old-fashioned machines running multiple things, right? Because we're so small, that's the right size for us. But this could, in theory, scale really wide. So that's kind of neat. And it should play nice in a, like an AWS or a fast, open fast environment. There's a weakness. Newt is an experimental prototype, right? It's not, this existed all of 6 weeks. So that is a definite weakness. So while I'm excited about Newt, that's what I'm playing with. I want you to really think, though, about the other things it talks to. Pandoc server and PostgREST is a JSON data source, because that's the muscle. That's the meat of it. The other thing is Newt does not handle file uploads. I did that on purpose. I wanted to keep Newt simple as a prototype. Will I handle file uploads? Possibly, right? I could see passing through to like a min.io instance as a way to talk to us, S3 or something like that. But right now it doesn't. So you're not going to build an institutional repository on Newt right now, not unless you have a parallel system to handle uploads. The strengths, I think, in Newt are that it's built on really, really solid foundation. I didn't know about PostgREST until I started playing around with Pandoc. And then there was a Haskell group that I followed because I use Pandoc. It's written in Haskell. I don't write Haskell. And I stumbled across PostgREST. And it's wicked cool in the same way that Pandoc is wicked cool. So that's the newest thing on the street inside this package besides Newt. And it's almost 10 years old. It'll be 10 years old next year. And it's got a community. It seems to be alive, seems to be thriving. I had never heard of it. Now, part of that was I was a MySQL guy before this, but that was kind of amazing. But the rest of it is like ancient. I mean, not ancient, but it's old. It's venerable. But it's also stuff that's stuck with us. So SQL goes back to 70s, 90s for HTTP and all that stuff. This stuff got legs. This is going to be after our careers. They're still going to be using this. And not in the negative way that some people think about, like Fortran and COBOL. So it's I think it's worth investing in this set of technology because it's not a proven track record and it actually makes our life a lot easier. So what are the next steps for Newt? Since it talks to a JSON data source and Solr and Elasticsearch / OpenSearch speak JSON, that's my next thing I want to do is try setting up a Pandoc template that can take the output from a search result and render it nicely. I'm also planning to build some staff-facing applications this summer. Last year and the year before, I wrote some applications that used a JSON API and a static file server talking via JavaScript. Those are going to get updated this summer. So that's going to happen. As I mentioned, I'm exploring generating the models, generating those SQL setup files and everything from Newt itself, so you don't have to write that, because those are pretty boilerplate. They seem like a generator makes sense. And hopefully, if this has legs, you know, next year you're here to talk about it. Oh yeah, we're doing this. So that's my hopes. As I mentioned, there's some someday maybe things, you know, it'd be cool if Newt handled file uploads, because then we could build something like an IR on this much simplified stack. It would be really nice not to have to power up PostgREST, right? So, you know, you're just sketching a problem. This is sort of a rapid development tool, right? When you're sketching a problem, it's nice to just have a file. SQLite 3 is great for that. So there's possibilities there. If I had written this not in Go but in Haskell, I could have directly incorporated Pandoc, but I don't know Haskell yet. The other thing is, you know, if this has legs, if next year I give a talk, I hope that we start to form a community around it, because I think we could share YAML files. Like one of the projects I'm going to be doing at the end of summer is a control vocabulary list for our groups and CalTech people, and that's going to be built on this. Well, while your specific criteria are going to change, the general idea of there's a controlled list of people and groups that I want to feature in my feeds website or whatever, that's kind of general. And if you can modify a YAML file easily to meet your needs, then suddenly we can share stuff. The really important one, though, I think, is probably the SQL, because if as an example, I created an accurate model, say data site data, that's something we could share, right? And there's no, you know, you don't want to implement that multiple times. So that's kind of an interesting thing, share the SQL. And the last thing is Pandoc templates. If you're rendering out something from Elasticsearch or Solr, I'm sorry, that's boilerplate. Nobody wants to write that twice. So that would be great to share that, you know, maybe with some CSS hooks to make it pretty. So a community would be great if we get there. Here's some related resources. I'm posting this on GitHub in the CalTech library space. It's in Newt is the name. I also include links to both PostgREST and PostgREST. PostgREST is well documented. I really encourage you, if you're interested, to look at the community tutorials, because it took me a while to wrap my head around it. I kept looking for the magic, and the magic wasn't there because it was really simple. But it took me a while to step back to strip away those layers. And it was really looking at the community tutorials where I got, oh, it could do all these things. And then I decided, oh, I'm going to use it for the scenario thing, because I mean, they do some crazy things. They create self-services, and that's crazy. So that's it. And then, of course, Pandoc is lovely. If you do need to compile PostgREST, I recommend using GHC up. It's sort of like Rust up. It gives you a nice Haskell environment out of the box. They make compiling Postgres or Pandoc, if you want to get the latest version of Pandoc, makes that much more painless. Whether you're working on Mac OS or on Linux, ARM or Intel, it seems to work fairly well. Thank you. If you have questions?
So like Postgres, really cool. You don't have to write your API anymore. How do you do login in that world?
Basically, there's two ways, as I understand it. There's sort of the login for the service, and that's going to be defined in the configuration file. PostgREST also supports JSON Web Tokens, so that can be folded in by the configuration file. And then you're probably going to want to also apply rules that are application specific. So like, let's say I was making a metadata management application, then I'm probably have roles of like editor and you know, administrator and viewer or whatever, reviewer. So those I would define at the application level, and I would make, and this is what, again, why I would use a function for doing updates, whether it's a put or a patch or a post, right? Because the JSON API is RESTful. I would include a check in that function for the update. They would only allow updates going through the functions. Rather than allowing the API to, there's an API mapping for inserts, right? I would turn that off, right, in PostgREST. I would make it go through the function. So yeah, you actually have a lot of control. It completely teases out that whole mess of stuff we used to write in Perl, Python, PHP, you name it, JRuby, Java. Yeah, it's kind of neat.
Thank you.
Thank you.
Right on time.